Boom, we are live. Welcome, folks. I'm I Can Science That, and I'm joined today by 414 Keeper. Would you like to introduce yourself?
Yes, hello there, guys. This is 414 Keeper. I have a YouTube channel for flat earthers.
All right, very cool. We're here today to do a follow-up discussion. I posted a video some time ago about eye level, and you responded to it just the other day. And you responded something along the lines of the closing was something like, we should talk about this. And so here we are. Let's talk about this. Sound good?
Yes, sounds excellent.
All right. So something you and I talked about before the show, but let's share with everybody else. The philosophy I would like us to have for this discussion is not one of trying to change the other's mind, not one to sway the audience even, but instead to try to understand each other. That sound good to you?
That's excellent, yes.
All right. And so, like in the comments to your response video, there was somebody that posted something along the lines of saying this was a semantic argument. And I think that's a really interesting point. Words are hard, right? Words are just our clumsy way of trying to communicate something to the other person, some kind of idea or something. And it doesn't always work, right? Words have different meanings, words have different interpretations. And so, sometimes people say, words matter. I like to say it's the meaning that matters. And sometimes the words get in the way. So, what I'd like to do is we'll each try to explain our position. And the goal will be that the other person will ask questions until they understand what was meant by that, right? And we're not going to try to get into some kind of semantic argument. You cool?
Yeah, that sounds, yep. I totally agree.
All right. And yeah, we have a few people here live in with us, and hopefully y'all can participate along those same lines. You of course express your opinions respectfully, but also, maybe if there's follow-up questions, somebody doesn't understand and you want more information from either one of us, jump in the text and we'll try to respond to that. Okay, well, let's start with...
oh, you just went dark on me.
Okay, can you still hear me? Well,
I can hear you.
Okay.
No.
No. I can stop my camera. And maybe that will minimize my bandwidth. We can just do talking bubbles. Let me know if you can hear me now. Can you hear me now?
Yes, I can.
Okay, we'll stick with this probably for the most part then, just to try to help the bandwidth. Okay, so we're talking about eye level. The original video was, what was it titled? I have it right here. It's from a playlist I have called The Curve of the Horizon, and the video is just called Eye Level. And you responded to it. I guess we'll start easy. What is eye level? What does that mean to you?
I believe that eye level is that it meets the eye. So not necessarily is it going to be completely straight across from my eyes, but that it meets my eyes. You know what I mean? Like, it's not going down. It's not downwards.
It's not downwards. Okay, that one was pretty clear. I think not downwards from your eye. I think you mean that if you look out perfectly horizontal, you will be looking directly at the horizon. It will not be below that horizontal line.
Right.
Okay. And why do you think, I guess I should start with, why is that like a flat Earth proof, or is that a flat Earth proof?
Well, it is a flat Earth proof on the basis that beyond that horizon, it continues as far as there is no going downwards, a continuation of downward hill or down curvature.
Okay. Would it be fair of me to describe this flat Earth proof question to say that if the Earth were curved, we would expect the horizon to be somewhere below eye level. But
Yes.
if the Earth is flat, we would expect the horizon to be approaching eye level.
Yes.
Okay. And all right, I'm going out on a limb here. Would it be fair to say that since the word proof is being knocked around, would it be fair to say that if we could demonstrate that the horizon is visibly below eye level, that would prove the Earth is not flat?
If I want to be careful here because the way I think of being below, I think of it being as low and continuing to go lower.
Low and continuing to go lower, meaning as you go higher in altitude, it goes lower.
That it would continue to go low and sink down, or like continue
Okay.
to go downwards.
Okay, you broke up a little bit. I heard it will continue to go downwards.
That's pretty much, yeah, downwards, yeah.
Continue in what way? I mean, like, I could interpret that to mean that as I stare at the horizon slowly just descends. And of course, that doesn't make any sense. So what do you mean by continues to go downwards?
So my idea is that if we were on a ball, the horizon would continue to slope further downwards and decline past the horizon. And
Of
if the
course.
horizon were to lower, I mean, low as in like uh, a quarter of the way up from the bottom. So if I have a picture and the horizon is a quarter up from the bottom, that is the kind of idea that I'm thinking.
A quarter, you say a quarter up from the bottom. How do we measure
You
this
just went out on me.
quarter? Let me try again. You say a quarter up from the bottom. Can you hear me okay? Quarter up from the
Yeah,
bottom?
yeah, I can hear that.
Okay.
Yeah. So let's say, for example, I'm sorry, go ahead.
Now you said, let's say, for example, go ahead.
So if I have a photograph and the horizon is around the center area or a little bit lower, but it's not low as far as I, it's kind of difficult. Let me show you. Let me see if I can
Okay,
show you.
yeah. Let's see if you can show us what you mean.
All right. So I have here kind of a picture, if you can see that.
Yeah, let me try to make you
I've got a
big.
little person here. Okay, is that
Yes,
kind of where? So if we say that,
yes.
let's say we're looking out this direction, right? This is the horizon area, the globe, and this is where it starts to curve downwards. This is what I'm talking about. So
Uh-huh.
when I'm seeing the horizon, this is my horizon right here.
Yes, I see
But
that.
if I go start going moving upwards, then this is what I'm going to start to see. I'm going to start seeing that decline, right?
Excellent. Yes, I agree with that.
All
I
right.
totally agree
So
with that.
okay.
We would be able to, as we go higher in altitude, we should be able to see farther the horizon, we should notice that the horizon is getting farther away from us the higher we get in altitude, right?
Yes, but it should also be going down.
And it should also be lower from lower below like a horizontal straight line in front of us.
Right.
Okay. And I'm assuming that you're saying that these things you have not been able to observe.
Yes.
Okay. Once again, let me go out on a limb here. What if you could observe it? If you could literally see those two features, would you then say that means the Earth is a globe?
I would definitely.
Oh, you broke up. Try again. I heard I would def.
Yes. I just said yes.
Yes. So you'd be like, oh, I'm not a flat earther anymore because I saw this.
Well, it would cause me doubting, like, why am I a flat earther then if this is what I can see happening? But now understand that it's going downward. It also has to start tilting away. The
Right.
objects have
Yes.
to tilt away. I'm sorry.
Yes. Yes. The objects also would have to tilt away. Yeah, I agree with that. They would. Yep. I think we lost you, but I think you're back.
I can't hear you at all.
I think you're back now. I can confirm it is your bandwidth on your end that is rough.
I still can't hear you.
Okay. In the chat, folks, can you all hear me okay? Is my audio coming through all right?
Now I just heard that.
Yeah, it takes a couple of seconds for the chat to catch up. But let's see. I'd like to confirm from them. I'm fairly certain I'm coming through all right. Okay. We hear you both. There's been a few times when 414 has broken up on the audio. Are you guys getting that as well? Yeah, a bit robot-y, Shadow Falcon says. Yeah, I can. That's what I'm getting to. Not much we can do about that unless there's a way you can improve your bandwidth. But we'll struggle through. We'll struggle through a little bit because this is a conversation I want to have, even if it's not right. Even if it's not the best entertainment value, I think this is a conversation worth having.
Oh yes, definitely.
Okay, so if I can summarize what I heard from you, if the Earth were round, you would expect the horizon to be below eye level, and I'm going to define that to say that there's like I hope we agree what horizontal means. When I'm looking out perfectly horizontal, I would have to then tilt downward from that to see the horizon. Furthermore, when I go higher in altitude, I should have to look further down to see the horizon. Also, I would be able to see farther into the distance as I go up in altitude. And finally, that things farther away from me would be tilted away from me.
Yes.
Okay, and if all of those things were true, then this flat Earth thing wouldn't be convincing to you. You'd be like, no, I don't think this is true. But because you do not see any of these things, that's why you think the flat Earth idea is true. Okay.
Say that last part one more time.
Okay, because you've never observed any of these phenomena, you think the flat Earth is legit.
Pretty much, yes.
Okay, cool. All right, I basically agree with all of that, except I would point out that the leaning away part that you mentioned, if we just do like a really easy back of the envelope calculation, Like, how far away are you talking? How far away is the farthest thing you think you can see? Like that little ship you drew, for example.
Well, I know that our eyes only see roughly 3 miles, right? That's how far away the horizon looks to us, right?
Okay, so if the horizon is about 3 miles away, how much should something lean away from us? Is there any way we could figure that out?
I think it should start right there, don't you think?
But how
If
much?
there's
I don't.
curvature,
I'm not saying yes or no, because I agree that yes, it should lean away from us. How much does it lean? How would we even measure the amount of lean? Right? I mean, because there's lean a little, and then there's lean a lot, right?
yeah.
Would we be describing that as an angle?
I missed the last sentence or two.
Okay. Would we describe the amount of lean as an angle?
Okay, you're talking about something now that I'm, oh boy. Um, Math is not my best subject, so you'll have to bear with me.
Okay.
As far as I noticed that you also mentioned tilt and degrees, that's something I'm not fully understanding. So maybe you
Mm.
can kind of help me out with that a little bit.
Yeah. Let's see here. Let me see if I can present a screen here. Let's see here. Let me do a screen. Let me do. I'll do that. Share. So I got this going on. Let me move this over here. And I'm just going to pop it big. How do I pop it big? Boop. Okay. Okay, let me try and make like a little sketch. Can you see what I'm sketching? Let's have
Not
like a
right now. My
like a
screen just
whiteboard.
is.
Okay. Let's
Okay,
just do
yes, I
like
see it.
okay. Let's make like a curve. So we got like a curve. Let's put like a, I don't know, let's put like a building or something, right? And we're going to put it on the curve. Boop, right? It's like a building or
Yep.
something on the curve. And let's put a people. Come on. People. Okay, just Mr. Generic. Boop. Okay, Mr. Generic people is sitting here looking at the building, and you say, hey, I see how that building leans away from me. Right?
Yeah.
And my question is, how do we say how much, right? Because if is it leaning away from me? Like I'd say that's not leaning away from me, right?
Wait, I can't see your screen. It's black for me.
Okay, give it a second. I'm sure it'll come back in. Do you see it?
No, I just see it's circling and uploading or it says having trouble
Yeah.
connecting.
Yeah, your network, your
Is it me
bandwidth.
or is it you? I don't know.
It's you because I'm watching it on YouTube while we stream and I can see it fine.
Are you saying
Yeah.
something? Because I can't hear
Sorry,
you.
Bob. Sorry, Bobby. Oh, come on. Catch you later.
I am really sorry. I cannot hear you.
Okay. Hopefully it'll come back. And if that doesn't work, maybe we can switch to like Discord or something. When you can see it, give me a shout. I can maybe just switch it straight to black. Oh, I lost you. Okay. I lost our guest. Hopefully she'll pop back on. Turn my camera back on. For anyone who's hanging out, the guest 414 has said not really strong at math. It seems to me this happens a lot, but I guess this is just the way things are now. Is on a phone, only on a phone, doesn't have like a laptop or anything. Here she comes. Hopefully she's back. Okay, you are back. Are you back? Okay, and let me just pop it big. If and when you are back, yeah, a flat earther who is not particularly strong at math. Okay. Hello, are you back? And is also working strictly on a phone with poor bandwidth, unfortunately. That sucks.
Sure. Oh no, I don't.
Yeah, you're robot-y, but we're hearing you. Yeah, I struggle with bandwidth sometimes myself.
I don't see, I don't hear you.
You don't see nor hear me. Maybe switch to cell phone instead of Wi-Fi. You could try
All right,
that.
I see your picture. Or your screen, I should say.
You see the screen share?
But I can't hear you.
Is maybe the mic is off or something? I'm sorry, like your audio volume
Well, I
down.
just heard you a little bit, and then your mic went out.
Oh, okay.
But I can see your picture.
All right. Well, if you see the picture, maybe you could describe for us that that this building is not leaning away from us. And what I'm going to do is I'm going to lean it away. Like, okay, now that building's like super leaning away, right? Like big time lean.
Yep.
Okay, so the difference between no lean and big lean, I'm calling that an angle, right? I'm saying this is, so that's like 0 degrees. 0 degrees lean. Here's like 45 degrees lean, right?
Okay.
45 degrees, right?
Yep.
Okay, so how much lean is enough to visually verify? That's really, I think, a question you should ask yourself is, if it's leaning 1 degree, let's say here. Can I go to, where's the rotation option? No, it's, how do I, somewhere in here, there's the option. Yeah, there we go. Okay, it's at 39 degrees. Let's put it at 1 degree. Okay, is this building leaning away from us? Or is that level?
It doesn't look like it.
Yeah, that looks pretty level, right?
It looks like.
Okay, but I just typed in, that is literally 1 degree away from us. Right here. I don't know if you can make that out, but that is leaning by 1 degree, and we cannot see that because it's too small a lean. And she's gone again. For those who maybe she'll watch this back later, or for those of you who are interested in this, 1 degree is how far away from us. How far away does that building need to be from our observer to lean 1 degree? Anybody in the chat know? Try thinking. Do you know? Anybody else want to chime in? How far away do we need to lean? I'm sorry, how far away do we need to be? It doesn't lean. How far away does the globe say we need to go to lean 1 degree? We have Shadow Falcon, roughly 111 kilometers. Real Cygnus says 60 nautical miles, and Clive Wells says 69 statute miles. That's right. So yeah, 69 miles of the regular, like American miles, or 111 kilometers to get 1 degree. And we had just said earlier that the horizon was 3 miles away. So we do not expect to be able to visually identify the leaning of the buildings. Okay, cool. And she's coming back. All right, I hear you.
Okay, hello.
Hello, hello. Okay, just to recap what we just had said, there's a couple people, we were talking about this in the chat. You have agreed you can't really visually see 1 degree of lean. That's not enough lean to see. And 1 degree of lean would require that building to be 69 miles away. So you're not going to see lean. Globe or no globe, you will not see lean.
I agree.
Okay, so we can just take the lean part of the question and just forget that one. Again, it doesn't mean anything. But how about looking down below eye level? How would we, in your video, you had some like screenshots. Let's see if I can. Boom. I think people are seeing this, right?
I'm
Screenshot.
just seeing.
Oh, yeah, my bad. I did this incorrectly. Please hold. Your call is important to us. Response, yeah, this one. Share it. Boom. It's not a screen. Now, come on, Ricky. Come on. What am I doing? Huh. I see the two of us, not this. Okay, let me try again. Present. Let me just do, oh, maybe there's a delay. Let me do entire screen. Let's try that. Share. There we go. All right.
I can hear you.
And can you see the picture that one of the pictures you chose to demonstrate your idea that the horizon is eye level?
Yes. From the viewer point looking forward, the cameraman behind the camera, yes, not the person on the hill particularly.
Mm-hmm. Well, first of all, this one seems to be taken from approximately sea level anyway, right?
Yep.
So let's get higher. You had some more. Make this thing go away. Let's see if we got what else we got. What else? Okay, here's one. Oh, again, taken at sea level. I don't know how high, but maybe we can use this one. Oh, I want this one. Okay, here's one. I mean, we don't know how high up above the ground this was. Where's eye level in this picture?
When you say that, I would presume it to be right where the line is under the sun.
Why? I mean, how do we know that?
I didn't think of that. That's a good question.
Okay, I think it is a good question. I think it's the core question for me. Is when you say the horizon rises to eye level, I'm like, hey, great, let's test it. right? Let's design a test to see whether that's true or not. Put us back on, and can you see my screen?
I can.
Like,
I can
okay,
see you, yes.
check this guy out right here. This is what was the water level, just a homemade water level, $10 of tube from Home Depot, right? No, nothing, but it's just water in a tube, and I put some red food dye in it so that it would have more contrast.
All right, you skipped a second, so I'm not exactly sure what you said that I might have missed.
Okay, this is just water in a tube with some red food coloring.
Okay.
Okay, and there's two tubes, and they're connected here at the bottom, right? This is a big loop at the bottom. It's all water, right?
Okay.
And something you hear from flat Earth people a lot is water finds its level. Something you'd agree with?
Yes, absolutely.
Yeah, and here's try thinking. The water level establishes a horizontal plane of reference. He's saying this right here, this line and this line, they're lined up. So that is horizontal. That is perfectly horizontal.
Yes, I agree.
What's this?
That looks like the horizon.
Is the horizon at eye level, below eye level, or above eye level?
Now, see, this is a good question that you ask, but are you comparing the level of the water in the tubes to the horizon? Because maybe I'm not clearly understanding.
Well, this is perfectly horizontal.
Yes.
And this is eye level. If you raise your eye above here, you'll be looking down at this surface. If you go below here, you're looking up at that surface. Agreed?
Yes.
So the camera must be perfectly in line with that surface.
Yes.
Okay, and that surface is perfectly horizontal.
Yes.
And this is the horizon.
Yes.
And the horizon is below this.
So what are you referring? I mean, I'm not sure I'm connecting. So just oh, I lost you. Okay.
Okay. I hear you
So
okay.
to me, eye level isn't where that water line is in the water. It's where I see, because I can see the cloud or the mist of cloud above it. So eye level to me is just the flat horizon that it's, I guess, just that it's the horizon.
You say this is eye level.
Yes.
Does that sound a little circular? To me, that sounds circular. You said the horizon rises to eye level, and that's how I know that this is eye level, because the horizon rises to eye level.
Well, I'm not sure if I'm being confused because of the water in that you have in those tubes. If you're referring to looking at that means your eye level, so therefore the horizon looks to be below the water that's in the tubes.
The horizon is definitely below the water in the tubes
Yes.
visually.
Yes, I
Right.
agree.
What I'm saying is these tubes is how I'm measuring eye level. I need an independent way to say what is eye level, and so I'm using that. Like I don't know, it's
Okay.
not water, it's soda, but but if you just do this, right, just take a glass of water
Uh-huh.
and look at it. If you look at it with the water below your eye level, like I'm holding it now, it's below camera
Yeah.
level. We see the top surface of the water.
Yep.
If it is above the camera level, we're looking up and see the bottom surface of the water. I mean, this is kind of opaque, but you can visualize, I think, right? You'd be looking up. The only way to see edge
Yeah.
on, the only way to see edge on is if it is exactly at eye level. And I'm going to say that's about right there. So that's a way to find eye level and say, yeah, where is eye level? All right, just, you know, glass of water, find eye level. Line it up with your eye. Like, try this later on. Just put some water in a glass and just up and down until it's like, okay, yeah, right there. For me, it's like right there. My camera is actually right about at my eye level, so right there. And that's what I've done here. And then you can just look past and say, is the horizon above that or below that? Because here's the deal. This is a tiny little gap. It's fairly large in this zoomed in photo, but when you just get out there, you're going to see it's a pretty small little gap. And I should also say this is at 5,700 feet above sea level. 5,700 feet.
Okay,
Right.
so this is something I'm going to have to kind of look more into, I guess, because I kind of knew that the water in the tubes had something to do with the horizon, but I couldn't understand exactly, I guess, what you were trying to refer it to. So, I guess I never really thought about it or looked at it that way. I just assume, I guess, that anything that's across my vision, and when I look out, I already know that the horizon is going to be, straight out. And I know from my own experience going up, as I watch the horizon, it seems to go up with me. It doesn't go down, it doesn't stay down, it goes up with me. So
Right.
I guess maybe there's some things you can kind of teach me on about that.
Well, yeah, and I agree with everything that you just said. Although I just want to add, from my perspective, you've never measured it. You've just looked. You've just looked and said, yeah, that looks like about eye level. Is that fair?
I missed you.
Okay, let's try again. I think what you've done is you've looked at the horizon and said that looks to be approximately eye level.
Yes.
But you never actually measured it because you never had a reference for what eye level literally is. And that's what this is for.
Okay, I guess you're right about that because, since being a flat earther, pretty much whenever we talk about the horizon, we just say that it's eye level. And as you go up, it's eye level. So I guess I guess that's something I have to look into because I understand what you're saying.
Yeah, and let me plug, shameless plug here for my app. I do have an app that I released recently, and I would love for you to check it out and share it with other people, particularly who believe that the Earth is flat and believe that the horizon rises to eye level. It's called the Angulator, and it's just an app for your phone. And what it does is you can see that it puts a horizontal line on your pictures. And right here at the top, it tells you under the thing called elevation or ELV, that's maybe annoying. ELV, it tells you the elevation you're currently looking. So when it says 0, you are looking at eye level. So here's a picture I took. That's where eye level is. Right? And here's one where the camera is looking down, like down at 26.8 degrees. Right, I'm up on a ridge looking down at the highway below me, right?
Okay.
Okay. And it's even got a feature. I mean, it's made expressly for this purpose, really. It's got a feature where you can push the little button at the bottom corner. It's not shown in the screenshots, but there's a little button down in the corner. Yeah, here it is. There's a little button here. And then it will automatically take the picture when your phone is level. So you can say, oh, what is eye level? I don't know. Push the button, and then you can arrange your phone until it's at perfectly eye level right there. And then you get a picture, and you're like, okay, there's eye level. And then you could say, where's the horizon? Do I have one on here? No, I don't have one. So yeah, if you're interested in doing that, check that out. It's a great way, very easy, with just anybody's cell phone. You can go out and ask, did the horizon really rise to eye level or did it not? And then you can try the other thing you said, which was from ocean level, take a picture and then try to get up higher and take another picture and get up higher and take another picture and ask, does that other thing you said, the horizon should drop lower and lower and lower the higher I go? Right? And
Yeah.
does it? So that this is what I think people should do. This is what I do. I hear that claim. I understand the claim. The horizon always rises to eye level. And I understand why that indicates that I'm looking at a apparently flat Earth. So then I ask, did it really? So I'm going to measure it. And so yeah, this tool, and there's others like it, that you can literally measure and answer that question. Answer it for yourself, because do not take my word for it, and please don't take Parallax's word for it. Samuel Robotham. Don't take his word for it, because people could be telling you not the truth, right?
Yep. It's kind of interesting how much math you have in with your science there, with the tilting and the degrees and such. And I'm thinking maybe I should kind of learn it a little bit better so that I can use it more to my advantage than just be like, I really don't know what you're talking about, so I'll just ignore this part.
Yeah. Yeah, that's something that I've encountered for sure in these discussions. Is
I can't hear you or see you.
hopefully it'll come back.
All right, I hear you now.
Yeah. Okay. Something that I have encountered is a lot of math in this that turns people off. Like Dora says, math is scary. Math can turn people off. That's why, yeah, I've taken to try to have these conversations with a lot less math. Although honestly, you're humbling me, because I keep making the same mistake of just assuming people understand the things that I'm saying. Right? I mean, like when I show this, I'm like, look, there's eye level, and you're like, wait, what? Right? I'm like, it's in my head. That doesn't mean it's in your head, right? So it's important that we have these discussions and talks about it. Yeah, I don't know. I mean, we hear a lot of math in these discussions, and if you're not a math person, what do you do? Do you just ignore the math part, or you just pick somebody to trust? You say, oh yeah, that guy, he's good at math, and he says it's this, so I'm just gonna go with that. What do you do? What's your approach to math?
Well, my dad was excellent at math. And when I was a kid, it scared me to bring home my math homework because I knew how irate he'd get with me for not understanding or knowing the answers or being able to do the problems. So that's the image in my head that I get every single time I hear something mathematical, unfortunately.
Yeah, that's an interesting sort of place we could take the conversation. So yeah, you don't have good vibes about math, and it comes from your childhood. Is that what I
Pretty
heard
much
there?
so, yes.
Okay.
Oh, you just went dark on me and I can't hear you.
Okay. Hopefully, I'll pop back. Um, I often wonder if maybe that that forms the basis of how you think about these things. About when somebody comes to you and says the Earth is flat, um, and you found yourself inclined to agree, to believe them, whereas clearly your teachers in school always said it was round, right? They all said it was a globe.
Well, I guess I never considered mathematics even kind of because science kind of let me just go over something here with you.
Hmm.
Because of going into flat earth as much as I have, and this started back in 2012, 2013.
Oh, okay.
So that's when my journey started. And it actually started with the moon landing, which I know that's not even a topic we're discussing, but it
Yeah.
started with the moon landing and just kind of crashed and cycled and was like, oh my God. And, it just went from there. Um, so when math comes into it, I go from science, actually, I go a step further. Science kind of shows me a lot that we don't know everything, especially with our atmosphere. We don't know how that messes with what our eyes see. And that's our atmosphere kind of is a problem with vision a lot. So when we're looking at something and we're trying to figure out what it is we're seeing. Oh, you just went dark on me again. When
We
we're
still
looking
hear
out and
you.
we're trying to visualize it. Okay, good. We're just uh trying to figure out if what we're seeing is is real, and if that's what we're seeing and it contradicts everything that we were taught as a globe. You start going, well, that globe was an indoctrination because that's what I was taught to believe, not what I actually experienced or see for myself.
Right.
So
Yeah, that's a very
there.
common version of a story that I've heard from many people. I think you're describing something a lot of people feel. And if you can hear me here, I wonder if like we all get this. We're all exposed to this. And one day somebody says, "Horizon always rises to eye level." That proves the Earth is flat. We hear that. I think there's two ways we might react to it. A person like me, myself, is going to hear that and say, that's incredible. That would mean that I've been lied to my entire life about all of this stuff. Is it really true?
Yes,
Is it really true? I test it.
you're
I say,
breaking up on me.
okay, okay. Is it really true? And I test it and I say, whoosh, good thing it's not true.
I can't
Okay.
hear you.
All right. All right. I'll keep going and hopefully it'll fill in. What I'm hearing is that you encountered that same thought, the same meme of the horizon always rises to eye level that proves that we've been lied to our entire lives. And you say, you have a very different reaction. You say, yes, I knew it, right? Whereas I said, no way, couldn't be, right? But you said, yes, that is what I think is
Yes.
true. And I think that's at the core. That's the difference between us. You had mentioned, like before we started the show, people get really angry about this topic. Some people get very angry about this topic. And I hope that we won't. We're not going to get angry. But if we understand that our difference started way back when you didn't want to show your math to your father in school, is when I think our difference started.
I heard you say something like school, so I'm going to
Yeah.
say yes, it probably did start in school.
Yeah, it probably started in school, where you got a negative feeling about school, about what was going on at school, what you were being expected to do in terms of school. And I'd say I didn't love school, but I did love the material.
I heard I didn't love school, but, and then I didn't hear anything else.
Okay, I did not love school and like the process or how it was done.
I'm not hearing you.
But I did like the material. I did enjoy learning the math and the science and practicing that on my own, which is something.
I am so sorry, but I still don't hear you.
Okay, I think that's okay. Okay, you're muted. You've muted yourself. Hopefully, I'm coming back. I wanted to shout out one other thought, just because right before the show, I asked a different flat earther what his opinion was about eye level. And so I just thought he's not here. I thought I'd repeat it best I can. He said the horizon does rise to eye level, but when you photograph it or when you look, you can see the horizon below eye level. There you go. Looks like a second device. Oh, we may have lost you on the first one. Let me remove that one and add that one. How about that?
Hello, can I think I can hear you maybe.
I hear you. I hear you.
No, I can't hear you.
Okay, make sure your speakers are on and the device is not muted or whatever.
Okay, it's not.
Okay.
I can hear you now.
Oh, okay, good. I was just saying, sharing a different, one of the things you had reacted to in your video was that you've never met a flat earther who says anything different about
Yes.
that. So yeah, I don't remember who I've been talking to that said something different, but everybody has different ideas. First of all, don't put anybody in a bucket, right? Don't put anybody in one little box. But right before the show, I asked somebody what he thought, and he said he thinks the horizon does rise to eye level, but when you take a picture like this, or when you look, you see that it does not. But it does. He says it does, but there's some optical effect that makes it appear that it does not.
Okay.
So everybody's got their own ideas, and I just don't want to. I think putting each other into boxes is a good way to start arguments. Really, just Be open-minded about other people. That's my philosophy now, is just I'm going to accept whatever people want to believe about stuff. And yeah,
Well,
hopefully take it.
I was just going to say, I agree. I agree. That's all I was going to say, is that I agree.
All right, excellent. And hopefully what we've achieved is I understand very much what you are trying to say, and I completely agree with it every single step of the way. We are totally in agreement, except that I have then tested, I've taken it further personally. I feel that I have taken it further to where I have been critical of that statement that the horizon always rises to eye level. I did not just accept that. I've applied math, I've applied science, but I've even done this very simplistic, what I consider simplistic test of it. And also, you can use your cell phone, use an app like what I was pitching there, and you can test it for yourself and like go up in a plane and see, is the horizon below eye level from a plane, using some kind of app that tells you where eye level is. And yeah, so hopefully you understand my point of view, and I'll even give in that third point of view, which is that there are flat earthers that acknowledge this gap exists, and that they say that that's some visual effect. And I'm like, yeah, okay, cool, I get that. I would argue that now we've come full circle, though. Robotham said, or Parallax said, the reason I know the Earth is flat is because this gap does not exist. We show the gap does exist, and the response is, yeah, but that's just an optical effect. That does not count. I'm like, well, no, go back to where we started. Where we started was it was flat because this gap doesn't exist. So if this gap does exist, we should say, maybe we don't say the Earth is a globe, but this gap to me says it looks like a globe. Am I breaking up again? I'm saying this gap to me makes it look like a globe. Whether it is or is not, I think is a deeper question. You could keep going, but certainly to me it looks like. And hopefully with that we can understand. Hopefully we can understand that we can all have different conclusions, but it would be nice. Oh, we got a new. I was just saying, hopefully with that we can understand that it's okay to have different conclusions about this.
I am still not hearing you.
Every time you switch, you got to do something to turn the audio back on. Try that, whatever it was that you did before. Okay. Maybe let's see if there's anybody in the chat who wants to contribute something. Let's see, anything worth repeating?
Back. Oh.
You welcome back. Welcome back. Anybody in the chat have a follow-up question or comment that they think is worth? Boom. Try thinking says reality does not look flat when I see mountains. Yes, of course, of course. Would you like to respond to that, 414 Keeper? Try thinking says reality does not look flat when I see mountains.
Well, we shouldn't be able to see those mountains at all because they should be going away from view and therefore not able to see them.
You're interpreting that to mean mountains that are so far away they should be below the horizon.
They should be.
Right?
They should be tilted away, or at least uh not. We should only be seeing like parts of it, not the whole thing.
Right. Yeah. No, I think that's a really good statement that you just made, and I would encourage you to run with that, to embrace critical thinking, give it a big old hug, or give critical thinking a big bear hug. And when somebody shows you a photo and says, "Look, I can see the whole mountain," you should check and say, "Can you? Or maybe am I only seeing the top of the mountain?" Just do that, right? Because like the one side says you can only see the tops of the mountains, the other side says no, I can see the whole mountain. So don't just accept their word. Why don't we do some critical thinking on that? Okay, so yeah, something that I'm into is that one. Like for example, this is from Mount Wilson. I don't know what area of the world you're in. Do you have any mountains near you?
Well, I really don't get out that much. And I don't believe so. No, I'm in Wisconsin.
Okay, so altitude may be difficult in your area unless you take like a plane ride. I am very lucky. I'm in the Pasadena area, and there's mountains. So like you could drive up to Mount Wilson, and that's where you can get to 5,700 feet just in the parking lot, and you can see the ocean from there on a clear day. I don't know, it looks pretty clear out there today, but it's June and we have something called June gloom. It's always gloomy. In June, but in certain times of the year when you can see the ocean, that was one of these days. Even this is not super clear. It's LA. What are you gonna do? And then right out in the ocean, there's some islands out there too. And so yeah, I could take pictures from Mount Wilson out to Catalina Island, and then ask myself, do I see all of Catalina Island? Do I see the whole island, or do I only see part of it? And yeah, I think that's a really good thing to do. You should never accept somebody else telling you what you can see. You should be critical, right? That's what we're about. We're critical thinkers, right?
Right. Well, that's what I think I do. I mean, I believe that's what I do when I'm looking at something or when I'm visually seeing something. I believe that, I'm critically thinking, okay, is this what I see? And the hard thing is that I just don't see that we live on a ball anymore. I just don't see the curvature, and that's the big thing for me. That's another thing I would like to talk to you about or discuss
Yeah.
at another maybe, but
yeah. What I'm saying is keep going with that. It's like you say you don't see it, right? You don't believe it unless you see
yeah.
it. And I'm right there with you. But let's measure it. Let's look closer. Be sure, right? I mean, we don't see germs either. Hopefully you believe germs exist, right? You can look under a microscope and see them, right? It's like, oh, they are there, right? And same thing with the curve. It's like you're not just going to look out and be like, oh, yeah, look, it's curved. But you could do something like this, or take a plane ride take a plane ride and you use your cell phone with something like the angulator, and say to yourself, are these things that I've been saying, are they actually true or not? Or when somebody shows you a photo, I do this one all the time. Somebody shows me a photo of a mountain and say, look, I can see the whole mountain. Right? Look in this photo, I see the whole mountain. What we could do just from our keyboard warrior
I just lost
status.
you.
Okay. Somebody says you can see the whole mountain. We can go and find pictures of that mountain from up close and say, can you really? This is what the whole mountain looks like. Can I see that whole mountain? That's something that we can do, right? And to me, that is where critical thinking starts. Critical thinking, well, maybe it starts when you say, I don't know if that's true or not. But to actually get serious with critical thinking, you need to go and find out, not just like feel it, right? Oh yeah, and it doesn't feel like we're spinning, so we're not, right? It's like, well, okay, that's not really critical thinking, is it?
Yeah, I understand what you're saying.
Cool. Interesting. Try thinking. His thing is he's trying to say that mountains are not flat. And I think you'll agree with that. Mountains are not flat. Mountains are very bumpy.
No.
Mountains, they're like that.
Yeah.
As someone who thinks that the earth is flat, you're okay with mountains being bumpy, right?
I totally get that mountains have. Yes.
Yeah. So I don't know. I don't know what he's up to. He likes to say the earth isn't flat because mountains are bumpy. And I'm just like, whatever, dude. Right? That's not the conversation we're having. And he knows that. He knows. I don't know why he keeps doing that. Okay. Was there anybody else? Gary Wybanga was in here. He might have something interesting to say. What did he say? The horizon is a simple optical effect of angular compression, foreshortening, RC. That doesn't mean remote control. I don't know what RC is. Oh, Rayleigh criteria. Gotcha. Okay. That's what he says. Did you have anything you wanted to add to that? 414, does that vibe with you?
Yeah, I've heard that before. There's a lot of boy, there's so much I could say. Let me start with just saying that a lot of our atmosphere does distort things. It distorts our sun, I believe, and it distorts our impression of what we are seeing. So, yeah, I kind of agree with that in a way. So, there's just a whole lot I could say.
Yep. I don't know that his statement was actually completely correct, but there's truth there. The atmosphere is a thing, and it causes distortion. I can't imagine anyone would argue with that. Some people won't argue anything, but we know the atmosphere causes distortion. We know, you and I, we know, right? Yeah, I'm right there with you. Right there with you. But I'm back to the circularity of it. If Eric Dubay or Robotham says the reason I know that the Earth is flat is because this gap does not exist. This gap does exist, guys. So that reason, you need to remove it, right? You just need to remove that. You can't then use that as a reason. You could say this gap exists because of an optical phenomenon. like, okay, we could go down that route, but then you can't use the lack of this gap as a justification for something if we are literally looking at the gap, right? So
Yeah.
that's all,
Well,
right?
understanding that, I think I had a conversation or commenting back and forth, on some of these videos. I had a conversation with somebody that I didn't quite understand what you were referring to as far as the eye level with the water and using that as a basis for the eye level of the horizon. So understanding that, it's something that I definitely have to do a little bit of research and trying to understand a little bit more and figure out. But I also wanted to mention that some of these other flat earthers that have done experiments using infrared, they are able to see much further away.
Okay.
Um,
Let me
and
ask
it
you a
would,
question. Let me ask you a question. These flat earthers with their infrared that see much further away, they said they can see much further away. How did you verify that they were telling the truth? How did you apply critical thinking to say, is that really what he says it is?
well, you kind of got me on that. I guess I just assumed that they're telling the truth when they're pointing out mountains and the names of mountains around the area. And, like there's, I don't know if you've ever seen that one meme where it's got like 5 or 6 mountains in the picture that you can see all at one time and they're all listed and named.
And there's lots of those. I've seen many. I've seen many.
So that's something kind of that I think of when referring to, I just assume that they're telling the truth, I guess.
I'm going to have to respond with a wow. You just assumed they're telling the truth. But when NASA says they landed on the moon, you just assume they tell the truth too?
Yeah, I did.
But not anymore,
You
right?
broke up on me, so I didn't hear the whole
Uh,
statement that you
I just said
said.
not anymore. These days, you're pretty sure NASA is lying, but those people on the internet that have a picture of a mountain, they're telling the truth. How do we
Well, I
know
guess
who's telling
I
the truth? Somebody's lying. I'm going to give you this. Somebody's lying, right? Somebody's lying. I just don't know who.
all right. You bring up a good point. I guess I guess I would have to say that it would be complicated then for anybody to do, for an example, an experiment, use infrared to see, say that they see locations or mountains or whatever, and believe them. And I guess I'm kind of at a loss of words. I don't know for sure what to say.
Yeah, I think that's a good place probably to wrap it up. I think hopefully we've both expanded our perspective. Um, I'm excited with the idea that maybe you're going to go back and question something. Just pick one thing. I would say pick one thing that you're certain somebody was not lying. That would be like, no, this is a slam dunk, like flat Earth proof, right? And then dig into it, like really dig. Um, Start with the really easy way to dig is ask, what do the Globers say about this? I find a lot of people are in echo chamber bubbles where they've heard their own people and they haven't heard the other side. Just say, what does the other side say about this? Um, and and really weigh that and find out who's really telling the truth.
Well, for the globe part, I've made a list, rather long list, a lot of the assumptions that are believed in a globe and the curvature and whatnot. So I've actually made a list of where they're not literally facts, but assumptions.
Are
I'll
you
give you,
sure?
for instance, okay?
Okay, give me one. Give me your best one, right? Because if your best one doesn't hold up, then you can bet that the rest of the list probably doesn't either, right? So just give me your best
Yeah.
one.
Well, I don't know if this is my best one, but this is one where we have only personally dug as far as what, 8 miles deep into the earth,
Mm-hmm.
and
That's
it's
true.
it's only one account that's known, right?
What do you mean by one
But yet,
account? There
well,
was,
it's the deepest that we've dug.
yeah, that's correct. I don't think anyone's going to argue that.
Yet we have globe layers. We've got the crust, we've got the mantle, we've got the inner. You know what I mean? We've got all these layers, but we've only dug 9 miles, which we haven't even gotten past the supposed crust.
Yeah, yeah, that's cool. How deep into your arm have you dug?
I'm not following.
Have you ever like drilled a hole in your arm to see if you really have bones?
Scientifically, we
But
know
do
that.
you have bones? You know you have bones?
Well, I've seen people with bones sticking out of their skin, so yes.
Okay, but do you have bones?
Yes.
How do you know? If you never
Uh,
dug into your body, how do you know that you have bones? Do you really have a liver? Do you, I mean, is there some way you can know what's beneath the surface without digging there?
but if we've only dug 9 miles deep, I mean,
But is
we
what I'm
could
saying,
be.
is there another way? Is there another way to know what's below the surface other than just literally digging?
Oh, you mean like the radio waves?
That's a good idea. How
Or
about radio waves? Could we use radio waves to figure out what's below the surface?
yes,
All right then.
but
So what's the point? I mean, why do we bring up the 8 miles thing? Why does the 8 miles digging some kind of big deal? If you yourself told me we could use radio waves to see what's down there.
we can't see that far down with
You
radio
said with
waves.
rate.
Radio waves only go so far deep.
Oh, okay. Is there anything else we could use? What do they use? The people who say they know what's down there. How do they say
I'm
they know that? I mean,
well, they
that's not my field. I don't care.
science.
Right. Well, I'm generalist, yeah, but so I kind of do know. I kind of know how they do it, but let me spin it a different way. Can the Earth be round?
You're breaking.
Okay. Can the Earth be round even if it isn't made of the same layers that science says it is? I don't know if you heard that.
What? Okay, say it again.
What if the layers of the Earth are not accurately depicted in science books? Can the Earth still be a globe, or is that somehow related to this topic?
what I would what I would say is that it can't be a globe adding other things to it, it can't be a globe. But just for the fact that we can't get past the supposed mantle is
I
a
don't
big
understand how that's
assumption.
related. I don't understand how that's related at all. Can a flat Earth have
Because
magma
it's an
underneath?
assumption.
Can flat Earth have magma below the surface?
Well, we know it must in some areas,
Okay.
but
Yeah.
I don't think science knows completely everything that's underneath the earth.
I agree. We don't know everything that's underneath the Earth. Hopefully no one gave the impression. Am I back? I think I'm back. I think I dropped for a minute, but I'm not hearing you. Can anyone confirm? Okay, I am back. Okay. I don't hear you though. Yep, here we go. Okay, we're back. That was me. I dropped that time. Okay, we were talking about we can only dig. We've only dug 8 miles, and I think what I'm really hearing you say, if I try to understand you, I'm trying to understand. What I'm really hearing you say is that the science peeps tell us they know stuff, and you're very skeptical that they're being forthcoming with it, that they really know what they say they know. Am I putting the right spin on it?
I
I'll
missed
try
a chunk
again.
of what you said.
I think what you're saying is that you're very skeptical that the science folks really know what they claim to know. You feel like they're sort of reaching a bit. Is that
Definitely.
fair? Okay.
Definitely, yes.
And I understand that. I understand that point of view. And to an extent, I think I agree with it. There's an extent that I'm going to say you're right. In science media today and science education, I don't think we do a good enough job of drawing the line between how certain we are about various things. When we say something like, "Oh, the Earth's core is made of iron," you've heard that before, and we've never dug down there. So how do you know that? And it's like, well, here's a pile of science data we could give to explain what we actually know. And ultimately, it's not going to come down to it's made of iron. That's not accurate. Right? There's going to be a whole bunch more data, and it's boring, and nobody wants to hear it. That's where I stand on it, and I think I understand where you stand. I think your tolerance for that is much lower than my tolerance for that kind of speaking. Okay, I don't know if you're still there.
Yeah, I can hear you.
Okay. So yeah, you brought up that we've only dug to 8 miles, and therefore we can't really know what's down there. What we can do is we can bounce radio waves, and that can tell us something. We can infer that there's magma coming up from the ground. Okay, we got that. We can use seismic waves to infer some information about the structure down there. We can use gravimeters and detailed gravity surveys to tell, how the density varies down there. We can. Well, what am I missing here? Am I missing anything? Anybody want to add to that? I mean, ultimately, the way science is supposed to work is we do these studies, we try to find things out, and then we publish what we found. We draw conclusions. Sometimes we take the one true pronunciation of gravimeter. Yeah, am I pronouncing it wrong? PhD Tony's not here. Gravimeter, or is it gravimeter? I don't know. Anyway, we publish our findings, and then over the years we refine and change, and once in a while we overturn them, and we say, nope, turns out that previous best science was wrong, and we have graviometer. There's no O in it though. Anyway, and to me that's, yeah, I mean, right. Once in a while, it's very rare, the science community will come out and say, no, you know what, we were very wrong about X, that we were certain of it, but we were wrong. That happens. I'm cool with that. We learn new stuff. Okay. But yeah, I think a lot of people don't see it that way. I mean, I've even seen the memes where, like, people write the distance to the sun, science's best estimate of the distance to the sun over time. And it changes, right? In the earliest days, they thought it was, this distance, and then they changed it to this distance, and they changed, right? Yeah, and to me, that's like, yeah, that's science, right? We learn more.
Doing educated guesses, though, I mean, let me see. Assuming, making assumptions, like you say, as far as noticing, okay, we've got lava, we've got uh, you know, making assumed guesses as far as globe layers goes, I guess, is just too much assuming. That's how I see a lot of the science for the globe, is that it's a lot of assumptions.
Okay. Again, let's ask you. What's the difference between an assumption and, say, a deduction?
Well,
Is there a
okay.
difference?
Um, when you put the two words together, assumption means to me is that you're assuming. Like, I can look at something and say, I assume this plastic is made out of uh, these ingredients, right? I can assume that, but is it really? That's the point. It's like, is that the truth? Is an assumption the truth?
Okay, let's give you a concrete example. Let's talk about a concrete example from our discussion today. I think it's fair to say you assume the horizon rises to eye level. Whereas I have deduced that it does not.
Well, I could show you videos, and there's a video that I just saw recently, actually, that had a level in an elevator, and the gentleman did what he went up the elevator, and as he's going up the elevator, I guess he's like on a beach or something, so we have a horizon that we're looking out at. And as he's going up the elevator, the level he puts a level under the as an explanation of showing that it is level, and he goes up the elevator and it stays level, and it's still at eye level.
How high up did they go? I watched a video just a few days ago um, that sounds kind of like what you're describing, only they had telescopes that they were using at like ground floor of a hotel and or some building, and then also up on the like top floor of the building. Is that maybe the same thing or is something else?
This was something else. He had a
Okay.
camera. I believe he had two cameras, maybe a phone, and he was using the camera of the phone to help with the level. As it was going up, he was watching the level stay at the horizon
One
as
assumes it
it
was a
was.
glass elevator, right? An elevator you could see out of.
Yes,
Okay.
yes.
Yeah. 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 Real Cygnus says there's no horizon in an elevator. Well, must be like
Yeah.
a window, a glass elevator. Yeah,
Yes,
I would
yes.
think that would be a pretty good test if you're high enough. Honestly, how high do you have to go to see this gap? Like I said, this is almost 6,000 feet, right? Um, yeah, how high were they? I would.
Well, I
How high?
guess maybe if you can show me how to use math, I can figure out how to answer that better.
Yeah. Yeah, we can go through that. I'm almost out of time here for today. But yeah, I'd be happy to point you to some math or point you to some calculators, like the globe Earth calculators that tell you this prediction of how much that should be and how we could measure it. Um, yeah, and Professor Park says this isn't about math; it's about trust. Yeah.
Oh, I lost you.
Yep. We keep coming and going.
All right, you're back.
Awesome. So,
Now
yeah, I think the thing I'm going to ask you to do is be super critical, be a critical thinker. Um, of the flat Earth stuff, just as you have been a critical thinker of the anti-flat Earth stuff, and learn and grow. That's what I try to do.
I can do that. Yes, I'm very open to that.
All right, and what will be super cool is if you could figure out a way to do something like that yourself. Because I always say, like, it's about trust. This is something Professor Parks is in the chat saying right now. It's about trust. And people lie. People lie, and they tell you things that aren't true. Maybe they believe it, but it's still not true. If you go and you do it for yourself, you can trust that. No one is fooling you. So, yeah, find a way to do that, and then
Well,
right.
that's my problem is that back in 2012 when I was learning things and trying to discover things, I did the experiments, I did the legwork, I did a lot of research, I did use telescopes and my camera, and now I'm old and unfortunately I have a lot of aches and pains that don't allow me to get out like I used to.
Yeah, okay. I feel that. I feel that. I'm getting older myself. I'm fighting it the best I can. Um, maybe something we could work on doing is like tearing down the walls between uh, globers and flatters, right? Um, find somebody to work with and together come up with stuff. What I see very, very often is a flat earther will tell me, oh, I've done these experiments and they proved that the earth was flat. Try thinking is an example of that. Although he doesn't call it flat. I don't want to put words in your mouth since you're there, Bev. Maybe you can say what you would describe it as. But if he'd have talked to me about it, I would have said that his experiment does not show what he says it shows. That there's another perspective that is being ignored that whole time. And so one of the things I've been trying to do ever since I started in 2016 is to cooperate, to come together and say, if we agree ahead of time, this is a test that will determine this for once and for all, and then we'll do the test, right? Instead of just like everybody makes up their own tests that the other side doesn't agree with, right?
Yeah.
So yeah, I'm a big fan of that, but I've found it's very, very, very rare. So rare to the point where I have kind of concluded that most of us are going backwards. We have a conclusion, and our tests are designed only to validate our conclusion, never to challenge our own conclusion. And that is literally going backwards. Instead of going from like observation to conclusion, we go from conclusion to excuse for observation. Right?
Huh.
Yeah, you see it very often. I mean, like for example, like observation, there's a gap here. Conclusion, the earth is flat and some optical phenomena that I do not know how to explain causes this gap. And that's how people roll. Right? And I don't think that's how it's supposed to work.
Well, no, but like I say, math is not my forte. So therefore, a lot of math and stuff, and I'm sure there's a lot of us that can say the same thing, that it's the math isn't there, not because we choose to ignore it. The math is there because we just don't understand it, or we just don't, we just, it's too complicated to, understand.
Okay. Before we go, I have like 20 minutes. Let me give you my favorite zero math flat earth talking point. Zero math, no science. Does the sun go below the horizon at night? Visibly. I mean, when you go and watch a sunset, do you see it doing that?
Yes. Yes.
Okay, let me even screen share this because it's in your video here. You've got a capture that I was showing earlier. Let's see here.
I didn't hear that.
Boom. Boom. There you go. There's the sun making its way. There's the sun making its way across the horizon.
I'm sorry, I still can't hear you.
Okay, I'll try again. Here's a picture you shared of the sun starting to cross the horizon. Hopefully, we agree. There's the sun crossing the horizon. Can you hear me?
Yes. Yes,
All right.
I can hear you and I see it.
Okay. If this was not the ocean, but instead was a table, would you say that sun is going below the table? This would be a basketball that is behind a table. That's what that looks like. No math involved. Just that looks like a basketball going behind a table.
Yes.
How could that basketball be above the table and also be going behind the table?
It could be due to the atmosphere, the water in the atmosphere, the pollution in the atmosphere, you know?
No, maybe it just looks like it, right? Maybe it just looks like it's going behind, but it's not really. Is that fair?
Right. Right.
But what does it look like?
It looks like it's going down, like it's going down into the earth.
Right. It looks like it's going down into the earth. And that could not happen if the earth was flat. It would have to only be looking, it had to be some kind of illusion. Right?
Right.
So to me, what we just said was maybe we're not sure if the earth is a globe or if it's flat, but it looks like a globe. It doesn't look flat. There's some kind of illusion. If it's flat, there must be some kind of illusion at work.
Well, it this is two points I'd like to illustrate,
Mm-hmm.
just to say out loud. One would be that I have seen pictures of what looks like it's behind a globe. So I've seen those pictures and I've had those pictures in my head. See, what I'm looking at is that sun looks like it's going down, and in this picture there's no sun cast onto the wall, so I can't see that because the sun is casting that light all the way down towards the viewer. I can't say necessarily in this particular photograph that it looks flat because of that, the lit. So photograph, I would say that yes, I agree with you.
So you look at this photograph and you think that it looks flat.
Yes.
You broke up. You might have said no.
No, I said
Yes. Okay.
just because it's like your first with the basketball.
The basketball. If it were a basketball, you'd say that must be a curved surface that the ball is behind, right? Or it's going below it, right? It's going below it somehow, and we know that sun's not going below the earth, so we can agree that it looks like it's going below the surface.
Yes.
And so it does not look like a flat earth with the sun circling above it.
This particular picture, no.
Right. So, I mean, sometimes it looks like it could be a flat surface with the sun circling above it. I'll agree with that. But sometimes it looks like it definitely could not be.
Right.
And so what you've done, if I can summarize, is to say when it looks like it could not be a sun circling above a flat earth, that's an optical illusion. When it looks like it could be, that's real.
Well, we know that the sun's not going into the earth, right? Because that's how it always looked to me. It looked like it was going into the earth. Because I know there's a lot of miles. You know what I mean? Like, it looks like it's going into the earth.
I'm certain the sun is not going into the earth. I'm going to reject that as a possibility. Say it's not. No, sun's not going into the earth. The sun is above the surface of the earth somewhere out there in the distance. And yet, it is still below the horizon.
Yes.
The only way I can make that, not the only way, but the obvious answer then is that the the surface that I'm looking at is itself a curve, that totally makes that work.
I understand what you're saying.
Or we could
I can't hear
say,
you now.
okay, I guess, or we could say it's an optical illusion of some kind.
Yes.
But yeah, I'm back to the circularity of it all. It's like, do you believe the Earth is flat because of what you see with your own eyes? Because what we see with our own eyes is the sun going below the flat Earth surface, and we know that that is not correct. So there must be something else at play other than what we see with our own eyes.
Have you? Yes, I agree. I do agree with that. Have you seen any of the experiments that have been done where they show like a tabletop and a reference of the sun going down using plastic? Have you tried any of those experiments yourself?
I have. Yes, I have. Yes, I have. Have you?
I've done a quarter, and I don't have the plastic, unfortunately, to do the sun, but I've done the quarter where on a flat tabletop where I take it from camera view and I take it along the tabletop, and um, it looks like it's going away from the camera. I've done that, but I haven't
Okay.
done the one with the plastic.
Yeah. There's a. I mean, there's a lot. There's a lot of interesting things you can do with those experiments. I would say, depending on what look you want me to generate, I could craft the experiment in such a way to get that look. Because I actually know kind of a little bit about how that stuff works. I actually teach CGI at school. So yeah, the best way to do it, the most common way to do it from the flat Earth perspective is to put the camera slightly below the edge of the table. And then as the
Yeah.
coin moves away, it will sink below the edge. And as long as the camera's part, one of the things that's complicating is like there's a lot of math. I'm sorry, there's a lot of math. The size of a lens, has a lot to do with it. Sometimes I've seen demonstrations where as they change the focus of the camera, it literally moves the lens forward and back, which causes the effect. The out of focus is a big part of the problem because you can't focus on the coin when it's close and when it's far, right? Right. You have to change your focus, and when it's out of focus, it's all blurry, and you're like, oh, look, right. Yeah. I mean, right. It comes down to trust. When you see that the sun is below, your first thought is, what looks like the sun is going into the surface must be an optical illusion. And then it's like, can I reproduce that optical illusion on my tabletop? Right. And you kind of can, sort of. Not in crisp focus like that, but yeah.
I mean, I just have a regular camera that I use regular settings, and just a regular phone, a regular cell phone that I use that, to move it and see what it looks like.
Okay, well, let me challenge you then. Let me make it a challenge for you. Let's bring it back. Yeah, right. Yeah, this is it. Here's your photo. Hopefully that's being displayed. Here's your photo. I would like you to take some round object, any round object, coin, I don't know, coffee can, I don't care what, on the surface of a table, and take a picture that looks like this with it, where the coin is in focus. We can see the surface of the table. The water surface represents the surface of the table. So we want to be able to see the surface of the table. And I don't know, let's say at least 25% of the bottom of the coin is cut off in a sharp, straight line like that. Can you do that?
I can definitely try. I might need some assistance from my family member or something, but I can definitely try to do that.
Yeah, that's a great idea. Get your family involved. Have some fun with it. Right? It's like family science time. Yeah, see if you can do it. See if you can do it without putting the coin behind the table. Remember, we have to be able to see the table surface, and we have to be able to see a sharp straight line, not a blurry out of focus, not a blurry out of focus table, not a blurry out of focus coin. We have to see a nice sharp straight line. And if you can do that, then yeah, I think you have every reason to believe that that's what this, that whatever setup you do on your table is what that is doing. That sound legit?
Yeah, okay. Yeah, I will do my best.
All right. Yeah, cool. Yeah, and you feel free to choose your eyeballs too. Just eyeball it. Try to, because our eyes don't have nearly the focus challenge that a camera does, right? Because we can just, it's just like automatic. You just look at it and it's focus. But yeah, you can't share your eyeballs with people on the internet. Okay. Yeah, let's talk again. Let's do follow up and see if you've changed anything or if you've come up with something that you think I should take a closer look at. Yeah, many future conversations.
Yes.
All right. Thank you for coming on, and thank you for all the guests who've been here. I got another meeting that starts in less than 10 minutes, so I'm gonna bounce. Thanks, everybody.
Thank you. Thank you so much.
Bye.
Thanks to everybody for coming. Bye.